So we are now officially going to start day 3 of CAD bootcamp. Sorry, day 4. I'm getting my days mixed up. Day 4 of CAD bootcamp, and we're gonna take the skills that you learned over the past few days and do a practice example in class, so you can test whether or not you really got the concept. So for this project, we're gonna be building a VersaFrame cube with gussets. So if you guys aren't familiar with what it is, that's fine. I'll be building it so you guys can build it along with me. It's going to use basically every single concept that we learned these past few days. So I hope that all of you guys remembered what we did. So let's get started. So the first thing you want to do is create a new part. So basically what a VersaFrame cube is if you guys aren't familiar with what VersaFrame is, it is this box tubing that we use in robotics made out of metal, and it has holes in it. So you have two options for this. Obviously, since I mentioned it's for robotics, you can just download it, the CAD files off of the website, and just use those. But in most cases, our team actually chooses to make them custom every single time, just because it actually saves money if you make them yourself, like in CAD versus downloading it off the website, which sounds really odd, but it's because this is actually really easy to make. So I'm just going to speed run. So you're going to take the XY plane. You're going to make a rectangle. The dimensions are 1 by 2. Okay. Uh-oh, that did not go. Okay. So then you're going to dimension that to be 2 inches. So it's like a tall, skinny rectangle. And then you're going to offset it. So I'm going to offset this towards the inside by 0.1 inches. Okay, you're good. After that, go ahead and extrude this. I'm going to make everything 10 inches just to make everything easy. So I have to select profiles. So I'm going to select this outside. Okay. I said 10 inches, so that would be fine. And I'm going to go ahead and click OK. So now we have this frame, right? And then what you're going to do is you're going to start a 2D sketch on this side. You're going to make some holes. 0.188, dimension them. So from the, I forgot, you have to project geometry. Project geometry, I didn't really go over it that in depth, but it's something that you need to do if you're creating if you're starting a 2D sketch on another already pre-extruded surface. So that's just something that you need to do. Dimension, from this circle to here. You want this to be 0.5 inches, and you want it also to be 0.5 inches from here. Okay, perfect. You're going to extrude that. For this case, you're going to reverse it, so it'll switch to a cut extrusion. And what you can just do is through all. So that's perfect. So you go ahead and click OK. You have this one hole, and then what we're going to do is use the rectangular pattern tool that I taught you guys earlier. Earlier when I taught you guys, I showed you guys how to use the tool in Sketch, but in 3D, it's basically the same thing. You just select the feature that you want to be patterned, and then you just select the direction. So in my case, I want it to be this way. 1 inch apart is fine, and I'm going to put 10 because this is a 10-inch block. Click OK. You have a VersaFrame. Okay, so you can go ahead and save this. Give me a moment to find my folder. Okay, I'm going to save this right here. I'm going to call it VersaFrame. So basically, it's just like this metal tube. Save this. This is actually made out of aluminum. So I'm going to change the material to aluminum 6061. Doesn't matter that much, but just to make sure it's accurate. And then I'm going to Control S and save that. Perfect. Like I mentioned, you could obviously also download it off the website. So I'm going to show you how to do that too. You saw it. If I wasn't explaining it, it would have taken even less. But even when I was explaining and walking you guys through, it literally took like 2 minutes to do it. So that's why most people, we choose to make it custom every single time. But obviously you can choose to download it off the website if you want to. So for that case, this is available on Vex Pro. So you would go to the Vex Robotics /Pro website, and VersaFrame, like I mentioned, it's called VersaFrame. So you're going to go here, you're going to click VersaFrame stock, and you'll see it looks exactly like what I just CAD'd. Circles, it's like a tall, skinny rectangle. CAD files, if you preview them, give it a moment to load. you will see that this is a cube, but if you preview this one, which is the one that I just made, the one that we use more commonly for robotics, you'll see that this is basically what I just made. Okay, so you can go ahead and click download if you don't want to CAD it for whatever reason. You'll see it, and then with Autodesk Inventor, click Control O, the command we learned on the first day. Navigate to the download section. Make sure that it's all files, and then just go ahead and click this and click open. Okay, go ahead and click OK so it can convert. And then afterwards, you'll see that you have this very, very long one. You're gonna go ahead and click Control S, and then you'll see it's like this. But you might have noticed, wow, if you use the measure tool that I showed you guys yesterday, you'll see that this is actually 59 inches long. We actually only want it to be 10 inches. So in that case, what you would do is you would start a 2D sketch. You would start it on this side. For this case, you just project geometry of all of it because, as I mentioned earlier, you're starting a sketch on a pre-extruded surface, so it's a good rule of thumb. I'll explain project geometry later more in detail, but for now, that's all you need to know. And then you can just extrude. Zoom in. And then, what did I say? It's 59 inches and we only want 10 inches. So you cut extrude. You can tell it's cut extrude because it's like this. You're going to cut extrude at 49 inches. Okay. You can go ahead and click Control S, save it, and if you measure it, you'll see that it's 10 inches. So those were the two ways that you could have gotten VersaFrame. I prefer the one where you just make it. It's easier. You don't have to navigate to the VexPro website, but it's really up to you. Okay, so now that we've gotten that done, we're going to start working on the assembly. So this is where we're going to be putting everything together. Wait for it to load. Okay. So this defaults a place from Content Center for whatever reason. Make sure it's just a place. Again, I'm going to navigate back to the folder I was earlier. So not that folder, this folder. Okay, so this was the VersaFrame I just CAD'd. For cube, I'm going to put a couple down. Like when you were in the part file, you couldn't really tell, but now if you look at it here, you can really tell that it's made out of aluminum. So I'm going to put it here, and then using the rotate buttons that I showed you guys a couple days ago, put it here. We'll need another layer for the top. We'll rotate the Y again. We'll need another layer for the bottom, and then rotate the X because we'll need the 4 pillars. Okay, and then go ahead and click Escape. So I'm going to start off by grounding one of them. This is just good practice. Just ground your most important piece that you don't want to move. In this case, I don't have a most important piece, so I'm just going to ground a random one. But make sure you only ground one piece because otherwise it'll cause problems. And then for view, you can go ahead and change the visual. If you go to the view tab, go ahead and change the visual style, shaded with edges, so it's easier to see the edges. It looks less realistic, but if you want it to look realistic, you can just go back and change it. So navigate back to the Assemble tab, and you can start using the constraints that I showed you guys yesterday. So since this, okay, I made a small mistake. That's not super fun. Okay, whatever, it's not a big deal. I'm just gonna move on. So constrain. You can start constraining everything together. So here we have this. You can use the flush constraint, right? Because I want to make a cube. Right now it looks sort of like a mess. So I'm actually gonna drag it around a little bit so you guys can better understand what I'm seeing in my mind. So we have this bottom layer of cube here, and then we have this top square here, and then these are the 4 pillars that sort of connect it. So you can sort of tell that's a cube shape. Okay, so what I'm going to do is actually make it a cube shape with constraints. So go ahead and click this. You can use the constraints. Now I'm gonna now that you guys have an idea of like how I'm using each piece, I'm actually gonna separate them because it's very inconvenient to look at them like this. Okay, now that they're a bit farther apart, easier for me to move. Okay, constraint. First step, select this, use the flush constraint. Select this and make sure that is flush with this. So you'll see that now they're on the same plane. You're gonna click apply, and then now you have 2 choices. What I would usually do is just click this and this surface, flush them, but obviously metal is intersecting metal. That's not something that can happen in real life, and just offset it. For me, that's something I would do because I think like dragging and rotating is really annoying. But so, if you don't want to do that, you could also have alternatively just selected this face and just rotated it this way, click this, and then just used the mate constraint instead of the flush constraint. So either way works. Go ahead and click OK, or apply actually. Go ahead and click apply. And then I'm going to continue flushing. I'm going to flush these two faces so they're together. Okay, so now you'll see you can't move either of these, and they're a nice little right angle. So you're going to just continue doing this for the rest. I'm just going to continue demonstrating. So you want to flush. It's at this point it's pretty repetitive, but it's good practice to make sure that you have your constraint skills up. Okay, go ahead and click. You can click apply. You can turn around. Okay, and then you just keep on doing this. So someone asked in the chat what the bang noise is. So that's the noise that Autodesk Inventor automatically makes when you are constraining things together. So if the constraint works, it's going to show have that like banging, clicking noise that you've heard. And if it doesn't work, though, there's going to be like an error message noise. There's going to be like a little bleep. Okay. So I'm going to continue constraining. I'm going to use the flush constraint because again, I just prefer using the flush constraint for things like this, and then offsetting. For me, it's just easier. Again, preference, it's up to you. And then constrain the vertical, flush these two, apply, and then flush this. All of you guys are pretty familiar with how a cube works, so it doesn't need too much explanation, but you know, just constrain and then keep on constraining. Something I haven't really talked about is this little cube over here and this little toolbar. So these are all tools to help you like navigate around. Like you can spin with this one, you can click home. You can choose the different views, like exactly front, exactly side, and everything. And then you can also use this. You can orbit, stuff like that. It's pretty self-explanatory. If you just click around, you'll figure out how they work. So this is actually, besides practicing how good you are at constraining, this is actually also really good to practice how good you are at navigating around in Inventor. So it's like killing two birds with one stone. It's a really good exercise. I hope all of you guys are following along and just sort of catching along with me. This will probably take like a couple more minutes and then we should be good. So just continue doing that. I will continue catting. Now I'm sort of working on my top level, if you can see. And again, I'm using a lot of flush constraints. Oh gosh, okay, that's not what I meant to do. For most things in Inventor, flush and mate are basically interchangeable, so you don't have to worry too much about the differences between them. But yeah, it's just really, a lot of it is just really based on preference. Okay, so I made a small mistake here, you guys can notice. I actually did not do this correctly. I should have done this on the inside. Yeah, so for that case, in that case, what you could do, really simple, you would actually have to make a copy of this in the file, because if you guys can see, you'll see that my thing is exactly 1 inch too short. So this isn't the best way to do everything, but just for ease, I'm just going to start a 2D sketch, which you guys can do in assembly. It's not something that you do too often. You can just start a 2D sketch, right? Okay, wait for Autodesk Inventor to load a little bit. Okay, and then you can just project geometry, okay. And start selecting these lines again, because you are starting a 2D sketch on an already extruded surface. And then I can just I can just select this profile right here, flip it 1 inch, and okay, I do not know why it caused an error, but I will try that again. If it doesn't work, it's not a big deal either. I'll show you guys another way to do it. Extrude. Oh, okay, I see, I see. Oh, I see. Okay. Okay. So actually, when you're I've done this in the past, but it seems it's changed a little bit. When you're starting a sketch in Autodesk Inventor, and you're like doing like Start 2D Sketch and all that stuff, you can actually only do that if you're doing cut extrusions, not actually making the extrusion longer. So in that case, what I could do is just go to this VersaFrame. I can change this extrusion right here by double clicking it. Yep. And then I'm changing this to 11 inches. So, okay, click OK, return. And okay, what you'll see is that it changed a lot of things as well. Everything got increased by 1 inch. So obviously everything is shorter now. In that case, you can just go back and edit the previous ones and continue cutting them and extruding them. I'm actually gonna undo what I just did, like making this thing 11 inches, because I think it's actually sort of bad. Okay, so now we're good. I'm actually going to do, remember that part that I downloaded earlier when I showed you guys that you could create it yourself or make another part? I'm just gonna open that really quick. Actually, I'm just gonna place it in here. So that one is in a different folder. It's in this one. I'm gonna open it. Okay, I'm just gonna place one here. If you double click, it will open it like just isolated like this. Alternatively, you could also just right click open. I'm gonna change this extrusion right here, and I'm actually gonna make this 48 inches. 48 inches? That's okay. So then if you measure that now, it's 11 inches. So I'm just going to save this. Okay, this is 11 inches now. And instead of I'm changing this part, which was way too short, I am going to delete this part and replace it with this part. So it asked me if I wanted to delete component dependent sketches. For my case, I'm just gonna click yes. Okay, I'm gonna continue constraining, which is sort of repetitive, but sort of a good way to practice. Sometimes CAD can get really competitive, but that's a huge part of it, especially when you're working with a lot of rectangles. Okay, continue. I'm going to continue flushing, and you'll see now you'll now see that if you look at it from the front, it's not too short anymore, so that's perfect. Okay, so I'm going to continue working. You guys can continue working too. I'm going to change orientations to do this. So the keyboard shortcut for constraint is C, if you guys wanted to know that. Keyboard shortcuts are actually really useful, especially when you're doing all these very competitive things. Okay, I'm gonna view it from the front and back, make sure everything is good, and then I'm gonna continue constraining. At this point, you guys should be pretty familiar with like how to build a cube and constraining everything. Again, see, in this case, this offset inside instead of outward. So again, reminder from yesterday, just put a negative and it'll fix itself and change direction. And then continue applying constraints, flushing. And okay. Now, oh, I see what I did here. So if you guys look at here, I actually made a mistake because I was going too fast. It's like flushed right here, but it shouldn't be here. It should be flushed right here. So in that case, what you can do is you can click the plus and you can see all the constraints that it did. So I'm going to right click this one and I'm going to edit it. I'm going to put an offset of 1 inch the other direction. I'm going to click OK. And then that's the right one. Okay, that's good. But I'm actually going to edit that one and make that offset 0. Okay, so you'll see I went here, I changed some stuff. I tweaked a few numbers and it's fixed. Okay, so now I'm just gonna continue constraining using the flush constraint and the make constraint that we went over yesterday. So that's good. Click apply. Flush this top and this bottom. Offset of 10 inches. The other direction, click apply, flush these two, apply, and then just continuing. You can for these constraints, there's a lot of ways you can customize it again, like I mentioned. But it's really important to sort of keep track of what you did. And you'll see, obviously, for this one, I want to flush this side with this side. But if I accidentally click this side, instead of reselecting, I can just click the second selection again, click this, and then it'll fix itself. Okay. So continue constraining. 10 inches. Okay. And then I'm almost done here. This goes to this with an offset of 1 inch. Oh, actually, let me look at this. No offset, 0 offset. I'm gonna rotate really quick. Yeah, okay, 0 offset. So apply, and then I'm gonna actually mate this and this to flip direction. Okay, apply, and then flush this side and this side. Okay, so this is actually too long now. It's cutting into this. So there's a couple ways you could fix it. You could either, in most cases, you would probably just make this one shorter. But for now, I'm just gonna ignore it because you guys are aware of how to make it shorter. And if you guys want to, I can go back and demonstrate how to make it shorter. But you just copy and paste, make a new part, and then after you make a new part, replace this piece, and then you'll be good. Okay, so we're almost done, thankfully. I'm going to continue to constrain. Don't forget to click apply. End of everything. Okay. I'm actually gonna do offset of damage. So in this case, this is also cutting into there. I'll deal with that later. So there, flush, apply. Now I'm actually going to show you with the last block what happens if you have an error. So if you have an error, like first you have to have some pre-existing constraints. So I'm going to constrain that together. I'm also going to constrain this together. Okay. So you'll see that that is an error because I just asked for something that isn't possible. So when you do something like that, it will bring this little thing up. You can either edit the relationship, cancel the relationship, accept the relationship, or diagnose the relationship. For simple relationships like this, usually I'll just choose to cancel the operation and redo it. But if you want to, you can edit the relationship. It'll bring you back to this. But if you don't make a change, or you make the wrong, or the change isn't correct, you can choose to accept the relationship. So what you do is, that means you'll tell Inventor, okay, it doesn't matter what's wrong with this. I just want to accept it and make this relationship true. So all the relationships that conflict with it will will become an unsold relationship. So that's usually not what I want to do. So again, I'll just cancel the operation because in this case, this is pretty easy. If you want to see what relationships already exist, you can just, again, click the little plus arrow on the side to see. I'm going to make this flushed and then constrain this with this. Offset 10 inches. Oh, 9 inches. Okay. So now you see at the bottom, it looks pretty nice, but at the top, it's intersecting with each other a lot because, mainly because of this little block here. But again, if you wanted to, you could just go back and change it. I'm not going to do it for the purpose of this tutorial, just because then it'll take a lot longer than necessary. And so yeah, there you have it. It's a VersaFrame cube. There's a lot of ways that you could go back and make this more pretty. I'm going to save this as VersaFrame cube, and there you have it. You're done. So you're just gonna click OK if it brings you up to anything. So yeah, this project, it used the rectangular patterns you learned, extrusion, 2D sketches, assembly, offsets, and all that stuff. So this is a very good practice, and I highly suggest you guys try to do this for practice on your own, or some like alteration of this. It's a great way to learn.